Hi, this is Michael Opdenacker from Root Commit. I was given the opportunity to teach the Devtool hands-on class at the Yocto Project Summit in December 2024. This was not the first tutorial of this kind. It has already been run by other people before me, and they are listed here. I mainly contributed to it by making it work on the 5.1 Styhead release. Well, the tutorial was a bit long and including time waiting for people to run the provided instructions, so I thought that a shorter version would help. Plus, I'm going to show what participants were supposed to run. This should make this video more useful than the simple recording of the tutorial. The slides remain the same though.
So, to introduce myself, I'm a contributor to OpenEmbedded and the Yocto project. I worked as a documentation maintainer until earlier this year, and I made several contributions to OE Core, to ALSA recipes, and added new functionality to the PR server to better support binary distributions. Some of you may know that I recently created a new company called Root Commit, and in this context, if you are interested in Yocto and OpenEmbedded in general, I'm offering a new Yocto project and OpenEmbedded training course that is 4 days long, available in person or online. It's guaranteed to have at least 75% of practical lab time, so you will have plenty of time and opportunities to learn by doing. You can find all the details on my website if you're interested. Alright, so what's on the menu today? We'll start with an introduction to Devtool as a bit of theory, never hurts, and then we'll go through 3 types of practical labs with Devtool that you can run on your own if you want. So the first one will be to use Devtool to create a local recipe for an external package that for which you can find the sources on the internet. That will be the Nano editor. So we'll use Devtool to create the recipe, to build the recipe, to deploy it to a QEMU target and test it on the target as well, of course. And then when everything is done, when everything is ready, we can export it to a layer to be able to share our changes with other people through a layer, right? The second one will be a bit similar. We will still work with an upstream package, generate a recipe, but then we will use Devtool to track, to maintain modifications to it, like local changes that we want to have in our project, like that are unique to our project. So we'll use Devtool to generate a patch and maintain this patch. The third one will be about taking an existing package in our layers, in our case OE Core, if I understand correctly, and then we will generate a local recipe that carries modifications to this package, right? And then we'll use Devtool again to carry on our modifications with the new updates to the package from upstream, right? So Devtool will help us again to merge our changes, like to reconcile our changes with the changes in the newest version. So that's the plan for today. So let's start with an introduction to Devtool. So Devtool is a collection of tools for working on recipes. You have Devtool add to create a new recipe based on sources, typically on the internet. You have Devtool edit recipe that helps you modify your recipe. You have Devtool upgrade that helps to upgrade a recipe versus some changes to your sources, like typically a new version on the internet. You also have Devtool finish to save your changes when you are done and you want to save the changes to a layer. Of course, there are many more options to Devtool. There's Devtool modify to modify an existing recipe. You have Devtool deploy target that will deploy the binaries corresponding to that recipe to a QEMU target or real target. Then you have Devtool undeploy target that is just the opposite. You have then Devtool build to build the current recipe, or a specific recipe actually that you're working on with Devtool. And Devtool build image, which will actually build an image with all the recipes in your Devtool workspace. So we will see that in detail. The first question is why Devtool was created in the first place. Our build system is really meant for building reproducible images from the same sources and not really to help with the modification of these sources. So the first thing people were tempted to do was modify the sources where they are extracted, that is in temp work. But this makes things complicated as the build system doesn't have a clue about what you're trying to do. You may then have to force rebuilding, generate patches manually from the modified sources, and may lose your work as, again, BitBake doesn't expect you to make changes in there. So Devtool was created to help new users write their own recipes, whether they are using BitBake or just the extended SDK. In a nutshell, Devtool helps with some of the tedious aspects of working with BitBake and the hardware. Of course, you can find earlier presentations about this topic, for which videos and slides are available. You'll find the links again in the description of this video. Anyway, if you're looking for information about Devtool, don't forget to check out the Devtool Quick Reference chapter in the Yocto Project Manual. Also check the documentation of the extensible SDK, as Devtool is precisely the cornerstone of this SDK. The manual also describes how Devtool can be used to patch the Linux kernel. However, the quickest and always up-to-date way to get information is from Devtool itself. So just run devtool --help and you will see the list of general options and subcommands. And then you can run devtool subcommand --help to get details about a specific subcommand, like the help you can get for Git subcommands. One very important aspect of Devtool is what is called the Workspace. That's a specific layer that it uses to create recipes, to modify existing ones, and produce patches. Now, let's start to have a look at how the Workspace is used through the various Devtool subcommands. So, you can start working on a recipe by using Devtool add, Devtool modify, or Devtool upgrade, for example. This creates a new recipe or a new copy of an existing one in the Workspace. Then you can run commands to experiment with this recipe, such as Devtool build to make sure that your recipe builds, or Devtool build image to build an image with the packages from the recipes in your Workspace. Devtool deploy target will take care of transferring the recipe build output to your target system, typically for testing. And then, when everything works, you can use Devtool finish to push all committed changes to a layer that you specify and remove the recipe from the Workspace. Note that you also have Devtool commands that don't need the Workspace, like Devtool latest version, which checks the upstream sources for a more recent version, or Devtool check upgrade status that can do this for all available recipes. And of course, with Devtool, you can deploy and undeploy to and from multiple targets, as Devtool deploy target and Devtool undeploy target are given the name of a target. That's great for testing that the binary for the same recipe works indeed on all the boards you want to support. By the way, there's also a recipe tool that contains the logic to create the recipes from sources. In particular, it's used by the Devtool add command. Recipe tool can also take care of creating and updating the bb-appen files and set the right variables in the recipe it creates. And now it's time to start the hands-on part at last. Get your terminals ready. So first thing to do, we'll first create an SSH definition for our ARM64 target machine that we will emulate through QEMU. And this way Devtool can easily connect to our targets. So I've already modified this file using Vim, not Nano, to tell you the truth. Right. So it looks like this. We connect through root. We specify a TCP port, etc. All the things we need. We name it QEMU. So whenever we refer to QEMU, SSH will know that those settings have to be used. Right. The next thing to do then is to clone Poky and start building an image. Actually, during the Yocto Project Summit, we did give participants a ready-made cloud image with some specific directories to work in, and those images made things easier and faster to run. In this case, I'm not running this demo. I'm running this demo on my computer, so the directories are a little different than on the slides. Don't be surprised. So let's do it. So first, let's clone. So git clone. We clone the sty head branch, which is the latest stable one at this time. yoctoproject.org/Pocky. This should take a few seconds, maybe 20 seconds or so. So there's no real need to pause the video. It should be fast enough, as you can see. Right, so it's ongoing. There's much less waiting time than the actual class, which we waited for the participants to complete their commands to. Right, so we go to the Pocky directory now. And then the next thing to do is to source the environment setup directory, or init. Right, and this time we pass a specific directory. It's just to follow what was done during the lab. And there were actually 3 types of build directories for the 3 hands-on labs that were being run. So here we stick to this. But otherwise, you end up in the build directory that gets created, right? And then we edit the local.conf directory in build, right? So let's set the machine we want to QEMU ARM64. We also want to have OpenSSH in the generated image so that we can SSH to the board. So we append to the list of packages to install. We append the OpenSSH package. Don't forget we've append a space before the string that you have at the beginning at least. And then since we want to log in as root with no password, we can use, at least in this version, things are changing, we can use debug tweaks to to do that, like to log in to the target as root with no passwords. Of course, don't do this in production, that's very bad. But for testing, there are safest ways of doing that now. After Styhead, you have safest ways to do this without the risk of leaving this in production. Right, and then we can bake our first image. So let's check that BitBake is happy, and then we'll let it run, of course, because obviously I have some objects in the cache, but it may take a little time. So let's stay tuned, run the same commands, and we'll be back in a few minutes. Thanks. All right, as you can see, the image has been built. So now we can move on and continue to the next step, which is to create our own layer. So let's create this new layer where we will store our new recipes, the recipes we create. So BitBake layers, create layer, and then we'll call it metafoo without much imagination. Good, so the layer is created. We need to add it to our bblayers.conf. So that's done by BitBake layers, add layer this time. There we are. Let's have a look at bblayers.conf. Indeed, you have metafoo that's added. So it's now time to add recipes to it. So let's see how we organize. So the left part of the screen is where I'm going to run BitBake and the development tools on the host. And then the right part on the bottom right is where we run stuff on the target. So I'm going to run a second set of instructions that will start QEMU on the target, right? Start the QEMU target. Right, so we have to go to the same directory as well. Yocto Pocky, we have to source the same environment. Right, and now we can start QEMU with the run QEMU command. Slurp is typically user-based, like without root privileges. No graphic, it's much easier. It's only in the terminal, and we have the output in the serial line. And there we are. So we can log in as root, and it's the machine we've just made with the image we just made, for example, as you can see. Right, so a few commands here. Logging in as root, as I started to say, was easy without a password, thanks to the debug tweaks feature that we added before. But that feature has been removed in 5.2, the OneNASCAR version. And there's a reason for doing that, typically to avoid production systems that use this forget to remove this when they move to production. Right. Last thing I can explain to is when you want to quit QEMU, when you are done, you just run Control-A, Control-X. Right, now it's time to start using Devtool for real, do something useful for it. So the goal here is to add a recipe for the external package Nano, assuming there's nowhere a recipe to be found for Nano. So let's use Devtool to create a recipe, at least a skeleton recipe for this, and see how it works. So we run devtool add, and then we pass the address of the sources on the internet. Nano editor.org. This Nano, v5, we've got v5. So we'll pick up the 5.8 version. Right, there we are. Let's get started. So you see it starts a bit big, it fetches the sources and does its own magic. Of course, it works in the bit-big environment, so it passes all the recipes that are available in our environment. All right, it seems things have been done according to the output of the command. So it seems so the workspace has been created. I think if you can see, yes, there's one now. It will get that. Should have guessed that the recipe is called Nano, as you can see from the output as well. And we will see also what it managed to do. So let's run devtool status first. Okay, yeah, so we have a recipe called Nano that's in devtool, the workspace, right? That workspace sources Nano. And we can check out the recipe that was generated. So let's first run devtool find recipe Nano. Of course, my bad. Okay, that's the path to it. So we could copy and paste the path, but that's not necessary. Because we have devtool edit recipe that will open the recipe file where it is. Nano. Right, there we are. So you can see it did guess license. The checksum for the license was generated. src URI is where the sources are found. There's a checksum for the sources. And indeed, it guessed the dependencies from the sources. So it guessed that to build Nano, you need to build the ncurses library, also the file application on library, and zlib as well. And it also correctly guessed, found out that it's an AutoTools based program. So you use configure, make install to compile it. And it's also based on get text and pkg config. So that's nice. It figured it out. And right, so now it also creates extra OE-conf that allows you to add some specific configuration settings to the way you build your recipe if you want. So that worked. That's quite nice. So let's try to build it, but that's the next slide. Hey, all right. So you see, I've just made an adjustment to the colors to make them stand out in between shots. So let's try to build Nano now. You don't have to be worrying about how to do that. Like Devtool builds it for you. So let's do it. Devtool build Nano and let's see. Yeah, so it starts bit bake as expected. Probably could run bit bake Nano as well. So it runs the several tasks that are part of the recipe, like configure, which takes a bit of time to detect the dependencies, and then compiling Nano, installing it, creating a package from the installed files, and there we are. Right. Okay, so it does build. So with Devtool, what do we have in the workspace? So typically the workspace is some space for working. So typically what you're working on, so recipes, batches that are generated, sources that are necessary to create the batches and to build, etc. Right, so let's check with the tree command what's inside our workspace in our particular case. Tree-d workspace. Ooh, okay, I'm missing it. Okay, so what we see is that we have the sources of Nano that were extracted and were used to generate the recipe. And we have a recipe for Nano as well, right? Plus other files. Right. The sources don't really have to be in the workspace. They could be elsewhere as well. Well, now it's time to deploy Nano to the target. So let's check whether it was built. So you can do that by going to doing grep Nano in temp deploy images machine, right? And then core image that manifest, right? Okay, so there's none. Let's move on to the terminal with QEMU on the right. So there we are. Let's try to run Nano. Not found, of course. So let's try to deploy it on a target using Devtool. That's the first time we see it. So I'm back on the left on my host and I run Devtool deploy target. Then you have to pass the recipe name first. That's Nano and QEMU. So that will copy the built artifacts to the target. That should copy the. All right, so let's move back to the right side and then run Nano. Oh, there it is. Okay, well, it's missing some libraries, but it kind of runs. Let's take advantage of this networking between the host and the target to talk about slurp versus stun and tap. So Yocto indeed supports multiple ways to connect to the QEMU machine. The easiest one is slurp, which means typically user-based connection between the QEMU target and your host machine. So here it's easy to do. You just run QEMU with the slurp option and you can run Devtool deploy target straight away based on the definition in the SSH config file. With tap, what happens is that the Linux kernel will actually create a real network interface on your machine that will connect to the application, the QEMU application, and then therefore to your target. So as it creates a real network interface, you need to have root privileges to do it right. And of course, it complicates the usage of it because you have to type in the sudo your password for sudo and things like that. It's harder to automate as well. So there are some cases where you want to use user-based networking like slurp or just tap, which is more advanced but requires some extra privileges. Now the next thing we want to do is build an entire image with Nano inside. So far we just copied Nano to the target. That was manual, and you see there are some trouble. So let's build an entire image with Devtool this time. So first let's stop QEMU. So I told you it's Control A. Oh, sorry, wrong window. Control AX, right? So that's a way to leave QEMU because we're going to modify the image, right? So I move on to the other window. So Devtool build core build image, sorry, core image minimal as we did before, base, sorry. Oops, my bad. This is going to take a little bit more time because it doesn't just build Nano. Or maybe yes. But you have to build the image again. All right, that's what happened. So it's still, it has built Nano when I was updating the image. So do rootfs, creating the image takes a little time. That's why we said in the slides that it takes a couple of minutes. But I have a fast machine. Hey, creating the PDX description as well. All right, so let's go back to the right side and then run QEMU again. And there it works. So you can notice a difference with the previous time. Before we just copied Nano, but without building, or without copying the dependencies. We just were copying the binaries for Nano and without the dependencies that were necessary. So that's why we had an error with a shared library that was missing. When we build the entire image, the dependencies get pulled automatically. So why didn't we just run bitbake core image base? We could have, but so far we hadn't added a Nano to the list of packages to install. So that's done automatically with Devtool build image with the recipes in the workspace. So that's nice, right? Now that this works, remember we picked an arbitrary version of Nano that may not be the latest one. Otherwise, it would be less interesting, of course. So let's try to run Devtool upgrade Nano. Yes, so the slides are right. So what happens is we have to move the Nano recipe to a layer first, as Devtool upgrade is supposed to work on an existing recipe, so that's in a normal layer, right? So let's do that. So as I was starting to say, we can't upgrade the recipe that's already in the workspace. So we'll have to put the recipe in our layers first, in our case, metafoo. So there's a command for this, devtool finish, that allows to copy the recipe from the workspace back into the layers where it belongs ultimately. And then we will be able to run devtool upgrade from our layers, from metafoo, and try to upgrade to the latest version of Nano, which is 5.9. So let's go ahead and try to run devtool finish. Devtool, oops, finish Nano and the target layer. Right, so source tree is not clean. So that's not because of us, it's because of some files that were generated when we ran Devtool build Nano. All right, so in the previous version of this hands-on, Devtool-F was supposed to address this, but look at that, -F, it's not enough. Right, so there's an issue that still needs to be investigated. So I found a workaround to make sure that the file changes are ignored in the Nano sources. So what you can do here is push D. Push D goes to a directory momentarily, and then you can resume to where you were before. Sources Nano. So that's where Nano was copied, and you see it's a Git repository in the Devtool branch, because you saw the color that changed on my prompt. So you can run git status if you want to see. Yeah, so you see those modified files. So I'm just gonna run git restore dot. Right, so the modified files, unnecessary ones at least, are gone, and then pop D, and you will see it should work better. Oops, I really meant that git restore did remove the modified files, and all the other files that we continue to see in git status were added ones that were ignored by git, so we're fine. So let's run again devtool finish. And see what we get. All right, yes. So it did move the recipe to metafoo, and we can delete the remainder of the sources that were in Workspace manually if we want. Right, so we're done with this part at least. Let's have a quick look too at our layers. So metafoo. Right, so there's a recipes Nano directory. Good. Right. I should have run the tree command. Right, yeah, so we have our recipe is definitely in metafoo now. So let's try devtool upgrade Nano. Oh, sorry, same mistake again. Right, so it tries multiple things. It's really trying hard, but not found. It's doing its best to find the upstream location of the sources, but apparently from the existing URL that we had, it's not straightforward. So ultimately, it should give up. Oh, it's trying 8.3. Well, these things have changed since last time. Let's see how this goes. Nah. Well, that's really a failure. The fetcher eventually gives up. So it did try 8.2 or 8.3 in our case, and this is not the latest one. So given that we started from 5.8, so yeah, it couldn't figure out what the latest version was. So let's try to give Nano a little bit of help, but not so much. We will just let it know that we want to use 5.9. We can figure this out by looking at the Nano sources and website. So let's go ahead and do it. Upgrade, just -v and the version we want, and let's try this. Oops. Oh, it was upgrade, of course, not update. I'm not moving this way. I save video compression space. Now. So it's coming. We have a recipe. Oh, it's making one. Right. Yeah. So you see, Nano 5.9 recipe was created. So let's try Devtool build Nano. So as usual, you have to build. So first running the configure script, which checks that all the prerequisites are there. That's a sequential step, so it takes a little bit of time, and you can throw as many CPUs as you want. It only runs on one CPU. So that's why it's slower than compile. All right, it built. Great, there we are. And now we can try Devtool deploy target Nano. To the QEMU target as usual. And then we can try Nano -- version if it works. Yes, 5.9, good. Did it what we wanted. So, by the way, you may wonder whether it's possible to redeploy a recipe a second time without having to clean up the first deploy. Normally it works, so I'm going to prove it to you. We can do it again. Right, and indeed it worked. Let's have a look at a few things that are done on the target. So you could look at the Devtool directory. Inside there's a nano.list file. It's a list of files corresponding to what was deployed. All right, you see all those ones. And so let's elaborate a bit. So when you no, sorry, that's not the one I meant. So yes, nano.list is created by Devtool for each package that it deploys, and you could have a look at the PokeScript lib devtool deploy.py for all the details about this script. So you'll find out that it creates a script that will be copied to the target through SSH. We'll make sure it preserves any files that would be clobbered. So that's the preserve file. It also generates a list of the files that are being deployed, so they can be undeployed, right? Of course, you have to know when you undeploy. So deploying starts by undeploying if there was files in .devtool, right, with the same recipe name. So let's try to undeploy now. Devtool undeploy target Nano, still recipe name and QEMU. Okay, successfully undeployed. And then we can check the contents of Devtool. It's empty now, so it did seem to work. Of course, now we want to finish our work and store our 5.9 Nano recipe in our metafoo layer. So let's do what we did before. So we can try Devtool, not on the target. Devtool finish, but we are very likely to hit the same problem as before. Metafoo. Wait, same problem. So let's move to, if you remember, the workspace, sources Nano, git status. We have modified files. So we remove them, we restore them to their original state as tracked by git. Pop-d. All right, and then we can do the Devtool finish. Right, it worked, good. So we've seen some Devtool commands that work with stuff in the recipes, but there are some Devtool commands that don't really care whether the recipe is in the workspace or not. So let's experiment with a few of them. like Devtool status. Yeah, so here it says the workspace is empty. That's related to workspace. Devtool edit recipe. So I want to have a look at the ETH tool recipe. It's not in the workspace, of course we know. So here's the recipe. Where it is, you see it's in Pocky Meta Recipes Extended. Oh, sorry, I didn't select the right thing. Now we can check also the latest version that's possibly upstream. Devtool latest version ETH tool again. Right. So the current version that we support is 6.10, but there's a version upstream that's 6.11. We could upgrade. Also, you have Devtool find recipe that tells you where the recipe is. We already knew from edit recipe, but that's a confirm. And then you can use Devtool search. Devtool search is like find a recipe matching a keyword, like either a package name, a recipe name, or some files that are deployed by the recipe. Oh, so there are multiple ones that match actually, because I was looking for ETH tool. Maybe there's some ETH tool files in the Linux headers and the core image ptest ETH tool, of course. So there are multiple matches, but that ETH tool, of course, here is the match we were looking for. But yeah, you can see search is quite powerful. If you're looking for a recipe providing a file, there you are. Don't hesitate to use this one. All right, we are moving to the second part now. We're going to use Devtool to help us create patches. Patches, yeah, typically are needed to add or remove functionality from tools we want to compile, to reduce the size on target, for example, but also to remove dependencies that are unnecessary in our embedded case. And sometimes we need also patches to fix cross-compiling issues because the initial makefiles or whatever were not really supporting cross-compiling. All right, so before we actually create patches, let us run another Devtool add to work with another example, a hello world example. So Devtool add URL. All right. Yeah, so it couldn't determine the recipe name, so let's pass it on the command line to help our tool. So you just need to add the recipe that you want to use. So auto tool Devtool example and the URL as before. All right, it worked. So we have a auto tool Devtool examples 1.0.0 BB recipe that was created. We're good. So let's try to build it. So it's a hello world example packaged by the Yocto tool. So it's gonna use configure, make install. And then of course Devtool deploy target auto tool Devtool example to the QEMU target as usual. All right, and then if I go to the target and run auto tool Devtool example, it did work, right? So hello world example working. So now let's modify the code so that we can generate a patch from our changes. So I'm gonna go to the workspace. So sources. Right, so you're getting familiar with this. I'm not using the exact command that is shown here. Everybody has his own preferred editor, of course. And I just replace hello world by hello Devtool. Easy one. Right. Now we can build and deploy. So I get back to the main build directory. I run devtool build tool devtool example. Great, it built, and then devtool deploy target. So recipe name, if you remember, and target name. All right, and back on the target, I can run it again. And now it's hello devtool, so it worked as expected. So now that things are working, we can do devtool finish to save the changes in our layer. Ah, source is not clean. Indeed, in particular, we modified the .c file. So here we have to create a patch. That's how we modify our recipe here. That's one way. So let's move Workspace. We want to keep our changes separate from upstream. So that's a good thing. We don't want to have like another recipe with different sources. No, that's not what we want. So here a patch is what we want. So if you check Git status, we are in the Devtool branch of the Git repository here. Yeah, we can see the changes. So let's make a change. Let's commit our changes so that we can generate a patch. So we update the salutation here. Right, so we did create the commit. We can get back to where we were and then run devtool finish again. Ah, I forgot dash F. Wait, so there's a patch somewhere. If I look for it, no, I can't find it. Oh yes, right, it's here. And then we can have a look at push the metaphor recipes auto tools, right? And here you see in the recipe the patch. So yeah, the normal recipe is here, but in the directory here there's a patch that corresponds to the changes we made. So we have a patch. Now we want to see how Devtool can help us manage conflicts. So the idea is to try to upgrade to a newer upstream release. And then of course this will conflict with the changes we made, and Devtool will help us resolve this conflict. So let's go ahead and try to upgrade. Devtool upgrade, sorry. Auto tool, Devtool example. Yeah, this is it's not enough. It doesn't have information, so let's try to help it. So this time again, we give it the version we try to fetch. So it's going to be -v 1.0.1 that exists on the same directory, URL, at least upstream server. There it comes. Aha, so it's actually unhappy first before we can do anything. It's not so satisfied with our patch. There are new requirements when you make a patch. It should have an upstream status flag so that we know whether the patch has been submitted upstream or not. So let's fix that part first before we can go on. So let's go ahead and fix the patch files, complete the patch file. Right. There is the patch file. So it's just about adding a few flags, right? So a flag sign of byte is fine. So after the sign of byte line, typically you can add your stuff like upstream status that was missing. So you see I used a well-known name, but this is my name here. Inappropriate. So that's a patch that's not appropriate for upstream inclusion. That's why it's called inappropriate. So we keep it for ourselves. Right. And then we can try Devtool upgrade again. Should be happy with the patch now. Happy with the patch, but you see a red line on the slides. Something will go wrong, but that's the conflict we are expecting. So that's not a big deal. Let's just wait to see this by ourselves. It's coming. Nothing moves, including me. Right. So there's a merge conflict, as you can see. It's not in red, but it stops because of that. So let's address this. Now let's try to resolve this conflict. What happens if you look at the details? Devtool did abort the git rebase operation, so you can't like go on and use git add and git rebase continue. You have to run the git rebase operation again by yourself. So let's do it. So we move to the workspace as usual. Right, we can run git status to figure out what's the status. Right. So yeah, no conflict. If you can run branch -a, you'll see the different branches. So there was a Devtool branch we are in, and there was the attempt to switch to 101, and also there's the orig branch with our changes. So let's try to resolve all this. By running the rebase operation again. So what we want to run is we want to rebase Devtool, the Devtool branch, the current branch, against Devtool 101. So Devtool 101, one of the branches we saw. Right. Okay, so the conflict is there as it was before. So we just need to, you see yellow color here, so we need to check out the sources and fix the changes. So of course Git conveniently put some markers here to help us see the conflict and fix it. So I'm going to remove the conflict markers. I don't want to have hello world, I want to have hello Devtool. Right. Just a second. Let's see what we are supposed to do. Yeah, we're supposed to keep just hello Devtool. And that's enough for us. But we still want to have this comment that was added. Yeah, that was after the marker, so just remove the markers. And there we are. And then we can move on and add our changes. Just before we resolve the conflict, we mark the conflict as resolved. Sorry, git add. Right, and then we can use git rebase dash continue. Yeah, so it shows I can confirm that this is the new commit that resolved the conflict. Right. So my commit applies to the new upstream. And then we can get back to the main build directory. And then we can try to see what recipe updates we would get. So we can use the dry run command -n. So devtool finish before actually running it. That's a nice command to see as well. -N. Yeah, so it's a way to validate the changes. So you can see here that we did replace hello world by hello devtool, and that's it. And a meaningful command was added from the upstream version. So we're good. So let's move on and remove the -n. And there we are. Let's finish the second part by checking the recipe now. Yes, so you can see there's a patch file in here. So let's have a quick look. Metadata, recipes, auto tools. Right, and you see the patch has been updated. It just replaces hello world by hello devtool, but the command was not there before. That's the context line. This patch is adapted to the latest version of upstream. So that's a success. All right, so now let's move on to the third part of the manipulations. This time, what we'll do is take an existing recipe instead of creating one and modify it as usual. So let's go ahead and do it. So we are going to run devtool modify BC, like a basic calculator. As far as I know, that's what it means, like this command line calculator. So it's copying into the workspace. That's what it's supposed to do. There we are. That's what it says. We can do devtool edit recipe BC again. There it is. That's the recipe. You can check it's in origin. For the moment, it's still in recipes extended. But now let's move on to the modified one, in the one that we will modify in sources. You can see all the files in there, right? So now let's edit the source file for BC. So it's actually main.c in the BC directory. I can go to this line. So I can change, make a really trivial change like BC usage here. And then I want to, of course, be prepared to run Devtool finish and create a patch. So I'm gonna, of course, if you run git status, you'll see one file was modified. So git add, I staged these changes. -s is for sign of by, so that's necessary. And okay, change help text. Right, change made. And now we can run Devtool finish. Again, recipe name and target layer. And we should see the patch that is created. Right, as you can see here, that's our patch. So what you could see is Devtool finish, did realize that the BC recipe is not in the metafu. It says that somewhere. Well, no, but let's see in metafu what we have. Recipe, I think it's recipe extended as in the sources BC. Right, so it did create a bb append file. So here in our layer, we just want to make some override, some append to the original recipe. Right, so it just applies a patch to the standard recipe that changes the usage information, and that's where we are. So that's nice because we don't override the upstream recipe. We just make a local change that we manage by ourselves. So of course, if we had passed the path to Poki meta where the original BC recipe is found, it would have modified the original recipe instead of creating a bb append like that. All right, now it's time to wrap things up. So a few words about the extensible SDK or ESDK. Well, you know, an SDK, a software development kit, is something you can deliver to people working with your images so that they can compile and add their own applications without having to have the full build system itself. In the case of the ESDK, it's typically the standard SDK plus Devtool, which allows to perform many operations that you could do if you had BitBake. So let's have a look here. You can see the Devtool subcommands in BitBake mode and ESDK mode. Right, so you see a few additional ones that the BitBake mode doesn't have. And that's typically because indeed the ESDK doesn't have BitBake and scripts. So you have you need Devtool to do a few of those things. Right, so Devtool is indeed the cornerstone of the ESDK. Now some ideas for contributing to a better future. Recipe tool, the tool that creates the recipes, can always be improved to be smarter at creating recipes from sources. And if you find some of its limitations, please try to help overcoming them. And actually, the Yocto project is one of the most welcoming and inclusive ones that I know. You will really feel useful and recognized when you contribute to it. Trust me on this. Okay, now it's time for a summary. So I would suggest you to try out Devtool on your own sources and recipes to build your own experience. The main commands you can remember from these presentations are Devtool add to create a recipe from a source tree, from a tarball that's either local or remote on the internet. You can also use Devtool modify to take an existing recipe and modify it according to your project needs. All right. And last but not least, you have Devtool upgrade that takes an existing recipe and upgrades it to a new upstream version that has appeared. And that's exactly the basis of the auto upgrade helper messages that you receive about once a week on the mailing lists. It automatically produces the patches that maintainers can try to update the recipes they maintain. Don't forget to check the documentation links that I shared, plus the other presentation links that I gave earlier. And of course, we welcome your feedback and your suggestions. Please, please, please. So you have the Yocto project mailing lists that are the best way to ask a question typically, because everything is archived. So whatever answer and questions you can get are publicly available to everyone that's interested in the Yocto project and can learn from your experience as well. You have the IRC channel that's listed here, #Yocto on Liberator chat. You have my email address, and of course you can also drop questions on the video platform I'm going to use to store the video. Thank you. Hey, that's it now. So I hope you liked this video. And if you want to learn more and support the creation of more videos like this one, you may be interested in my Yocto project and Open Embedded training course. So let me tell you a little bit about such courses. The first feature is that you can register individually, and that's what I call a public session, or in a group, like within a company, typically. The sessions are quite long. There's a lot of content to go through. It's 4 days in person, or 24 hours if it's online, like typically 6 half days of 4 hours. I also guarantee that there will be at least 75% of practical activities on the bigger playboard or on QEMU if you can't get the hardware when you're remote. You will also be really doing the labs in online sessions. I will support you the best I can remotely. And also the number of participants will be limited to 8. So you will have like a really good support from me, the instructor, and you won't just be looking at demos shown by the instructor. I also guarantee that the lectures will be short. They won't exceed 30 minutes at once. The goal is really to focus on practice and avoid exhaustive theory that could distract you from the key points. The learning techniques also try to be challenging, varied, and fun. I'm doing my best. And as I said, the public sessions, the one you register to individually, are limited to 8 participants. For the online sessions, you will also get lecture recordings you can get back to at any time if you want to go through the lectures again. And a nice feature too is that you will be able to use the distro of your choice, like the Linux distro of your choice, of course. I won't force you to use Ubuntu or Fedora or one specific one. You can use the one you already use day to day in your job. So, of course, the requirement is that it's supported by the Yocto project. So, thanks again for watching. Cheers, and stay tuned for more videos.